All right, so today we're going to talk about transversals. So a transversal is when I have a set of parallel lines with a line that crosses them, right? So that line that's crossing it is what we call the transversal. It's transversing the set of parallel lines. So what happens when we have transversals like this is we end up with some relationships. And basically there's going to be two options. The relationship is going to be either equal to each other, or they are going to equal or add up to 180, or they're going to be supplementary, right? So I'm going to zoom in here a little bit so you can get a better look at each of these that I'm talking about. And let's start with corresponding angles. So you'll notice when we have a transversal, we end up with two intersections. When the line crosses each parallel line, it creates four angles, right? A corresponding angle is an angle that appears in the same spot of each intersection. So for example, if I'm looking at angle 4 here, its corresponding angle, I'm going to use a pen. So if I look at angle 4 here, its corresponding angle is going to be in the same spot. So this is in the top left corner, so the top left corner of the other angle would correspond with that. That would be a corresponding angle. And these angles are equal to each other. Okay? They are the exact same. So if angle 4 was 110 degrees, that means 8 is 110 degrees. Okay? Another corresponding angle would be like 2 and 6, or 1 and 5, or 3 and 7. All of those correspond with each other, right? So if 1 was 70 degrees, that means 5 would be 70 degrees, and so on. Okay? Vertical angles, you should be familiar with this a little bit already. You've learned this in previous grades as well as the unit before this. But a vertical angle is an angle that is opposite from one another in an intersection. So for example, if I'm looking at angle 1, the angle that is opposite it would be angle 3. Those angles are vertical angles. And vertical angles are also equal to each other. So again, if 1 was 70 degrees, that means 3 is 70 degrees. Okay? Now, alternate interior. Anytime we're talking about the interior of a transversal, we're talking about all these angles that are inside our parallel lines. Okay? So these are our interior angles, 3, 2, 8, 5. Now, if we're talking about alternate interior, we're talking about angles on a different intersection on a different side of the transversal. So for example, if I'm talking about angle 3, the alternate interior angle would be on the opposite side of the transversal on the other pair of angles. So the alternate interior angle to angle 3 would be angle 5. Okay? Just alternate sides, alternate intersections. Okay? Another pair of interior or alternate interior angles would be 2 and 8, right? And our relationship here is that these are equal to each other. They add up to, or they equal to each other, and they would be the exact same thing. So again, if 3 was 70 degrees, that means 5 is also 70 degrees. Okay? Adjacent angles. These are angles that are right next to each other. They share a side. Pretty tough, right? So if I'm talking about angle 4, an adjacent angle to that would be 1. Okay? And they share that same side. Now you'll notice they form a straight line when you put them side by side, which means these add up to 180. These are supplementary angles. All these angles have 2 adjacent angles to it. So 4 also has an adjacent angle of 3. 3 would add up to 180 as well with 4. Okay? So for example, if I did 6 its adjacent angle could be 7 or it could be 5. Either of those would be adjacent angles. So basically, if I did 4 plus 1, it's going to equal 180. If I did 5 plus 6, it's going to equal 180. If I did 4 plus 3, it's going to equal 180. Okay? All those just add up to be 180 degrees. Okay? And then we got down to our last two here. So we've got alternate exterior angles. So interior was everything inside the parallel lines. Exterior is going to be everything outside the parallel lines. Okay? So alternate exterior angles is the same idea as alternate interior angles, but this time we're talking about these angles on the outside. So 4, 1, 7, and 6. Okay? So if I'm looking at angle 1, its alternate exterior angle would again be on the other side on the different intersection. Okay? So 1 and 7 would be alternate exterior angles. And these are equal to each other. So again, if 1 was 70 degrees, that means 7 would be 70 degrees. If 6 was 110 degrees, that means 4 is 110 degrees. Okay? And the last one you talk about is consecutive interior. Okay, so we already discussed how the interior angles are these that are inside the parallel lines. So to be consecutive interior, they just need to be on the same side of the transversal. So same side of my line that's going through my parallel lines. Okay? So for example, if I'm talking about angle 2 here, the other angle that's on the same side would be 5. Okay? That would be the consecutive interior angle. So 2 and 5 are consecutive interior angles. And these add up to 180 degrees. So 2 plus angle 2 plus angle 5 would be 180 degrees. So if angle 2 was 110 and angle 5 was 70 degrees, add them together, hey, it's 180 degrees, right? That's what you're doing with those. Now let's use these properties or these relations in practice, and let's do a couple problems. So let's look at like this problem, for example. It wants me to figure out this question mark, and I know this angle is 78 degrees, and I need to figure out what that angle is. So first thing I'm going to do is I'm going to try to figure out what's the relationship here. They're both interior angles. They're in different intersections on different sides of the transversal. That would be alternate interior angles, right? If it's alternate interior angles, we already discussed that those are equal to each other, right? So that question mark would have to equal the other angle. So that question mark has to equal 78 degrees. Okay, not too tough, right? Same idea on a lot of these. Like on number 8, though, these are adjacent angles, right? Because they share a side, they're right next to each other. So those would be adjacent. Adjacent angles add up to 180. So this question mark plus 56 has to equal 180. So to figure out the question mark, basically all I'm doing is I'm taking 56 away from 180, which means the question mark has to equal, let's see, 30, it'd have to equal 124. 124 degrees. Okay? And that'd be your answer. Okay, let's look at something a little trickier. So let's look at, let's say this one right here. Number 13. So first of all, my relationship here is they're opposite each other at an intersection. That means they are vertical. Vertical angles are equal to each other. So that means that 26x, and let me zoom in here a little bit so you can get a better look at what I'm doing. So that means that 26x plus 6 has to equal 28x minus 2. Now, this is just a multi-step equation, right? Remember, this is where you have to move the variable to one side and then solve, right? We don't have to worry about distributing or combining like terms really because there aren't any. So we're just got to move the variable. To move the variable, it's just like moving any number. You add or subtract, right? I usually pick the smaller number to move. It doesn't matter which one you move. You just move one of them, and you're going to end up with the same answer either way. So if I wanted to move this 26x, it's positive, so I'd have to subtract it. So I subtract it to each side. That leaves me with 6 is equal to 2x minus 2. Now it's a party problem, right? I got a best friend and acquaintance. Acquaintance is going to leave first. It's subtracting, so you have to add it. So you'd add 2 to each side, gives you 8 is equal to 2x. And then your last step is to divide. And your answer is going to be x is equal to 4. Okay? Not too tough. I know it looks like a lot of work, but really I just did, 3 things. Subtract the 26x, add it 2, divide by 2. And that's it. Okay? Let's look at another one. This one, these are consecutive interior angles. Okay? Now there's only 2 relations that add up to 180. That is consecutive and adjacent. Everything else is equal to each other. So if you can keep those straight, which ones are 180, it should make it pretty easy. Less to remember. Just remember the 2 that add up to 180. The other 4 are all equal to each other. Okay? So, and usually it's pretty obvious because, if they add up to 180, that means, one is going to be, obtuse and one's going to be acute. They're very different angles. They're not going to be equal to each other if one's obtuse and one's acute, right? So, that means they're going to add up to 180. So basically, to set this one up to solve for x is I add these 2 angles together, set them equal to 180. So I would have x plus 130 plus x plus 62 equals 180. Okay. Then this is another multi-step, and this one I do have to combine like terms, right? I've got 2 x's. Combine those, I'm going to get 2x. Okay, if my pen cooperates. And then I've got 2 constants. Combine those, 130 plus 62 is going to be 192. So plus 192 equals 180. Okay, now I subtract 192 from each side. It's a party problem, right? Getting rid of my acquaintance. Gives me 2x. Come on, pen. Don't die on me yet. Almost done. Oh man. Come on. 2x. 2x equals negative 12. Okay. Now, last step would be to divide. Divide by 2. X is equal to negative 6. Okay. Not too bad. Now again, x can be negative 6. Your angle can't be negative, right? But if I plugged in negative 6, I would get this angle would be 56 degrees, which is fine, right? If I plug in negative 6 there, that angle would be 124. Okay? So that's fine. The angle itself cannot be negative, but if you have an unknown number that's adding or subtracting in there, that can be negative. And that's perfectly fine. Okay, and that's all you're doing with transversals. You're either setting them equal to each other, or you're adding them together and set them equal to 180. And that is transversals.